All right, Unit 4. Let's see. The population of the town in 2023 is that starting population, 10,600. Is it experiencing exponential growth or decay? 1.02 is a number bigger than 1. So growth, because 1.02 is bigger than 1. All right, what is the population in the year? So this is 10 years later. So I'm going to plug in for t to be 10. 2020 is 3 years before. So I'm going to plug in when t is -3. And then I'm going to guess and check on the last one. I'm going to pause the video and check those answers. All right, so I got, these are my answers, 12,921, 9988, and in 33 years. So I plugged my function into the y equals menu with x as my years, and then, and then in the table function, I scrolled down until I got over 20,000, but you can also jump back up and check it at year 10. And that's where I got one of my answers. So there's my answer for year 10 and go back to -3. A bacteria population is experiencing exponential growth. It has 5 colonies and then 28 colonies 5 hours later. So P of X equals, it has 5 colonies. And let's see, 28 colonies 5 hours later. To find a growth rate, you're going to take your 28 and divide by 5. So your second value divided by your starting value. 28 divided by 5. So it has a growth rate of 5.6. And it's every 5 hours. So I'm going to do x over 5 so that I can plug in any hour that I want. And if I want to find the growth factor each hour, I can take 5.6 and just raise that to the 1/5 power, or the 5th root of 5.6. So growth factor of 1.41 each hour. And what about after 20 hours? So 5 times 5.6 to the 20 hours divided by 5, or I could just use 4 in my exponent. 5 times 5.6 to the 4th, it would be at 4917. 0.2 if you wanted to round it. All right, is 64 to the 1/3 power 4? Yes, because it's the cube root of 64. Are these equivalent? No, because this has a square root out here, not a cube root. Let's see, if I take negative square root of 15 and square it, I do get positive 15. The square root would go away, and so would the negative when I square it. And the cube root of 27, if I cube it, do I get back to 27? Yes, that's the definition of a cube root. So A, C, and D. A bacteria population has a growth factor of 3 each hour. What's the growth factor in half an hour? That would be the 3 to the 1/2 power, or the square root of 3 is equivalent. All right, 2 different substances. It looks like we're looking at a half-life of 3 hours. To write my equation, it would be 400 times 1/2 to the x over 3 power in the exponent. So I'm going to plug in 1, 2, 4, 5, and 6. So I could just do that in my y equals menu. 400 times 1/2 raised to the x over 3. Go to my table, start at 1. So it looks like I'm just going to round to 317, 252, 200, 159. I'll round 126, and then exactly 100. Here's substance B. Which had the bigger initial value? 400 versus 350. So that would be substance A, 400. Who's decreasing at a faster rate? This is taking 2 hours, and we said this was taking 3 hours. So B, 2 hours, half-life. Which substance will have a smaller amount at year 10? Oh, sorry, this is years. 2 years. So let's plug them both into the y equals menu. The other one was 350 times a half raised to the x over 2. Let's jump ahead to 10 years. And it looks like substance B has less. So B, it has 10.9 versus A has 39.7. So B has less. All right, write an exponential model. So let's see, y equals, it looks like I'm starting at the number 5. And I am at 1, it looks like I'm up at 10. So I'm doubling, so times 2 to the x power. This one I'm starting at a value of 3. And am I times a half? Because there's 1 1/2. So times 1/2 to the x power.